Great, thank you for that.
All right, I'll start again. So
yeah, start again. Sorry, apologies.
So hello everyone. So the intention of this presentation is to give a case study of what we have done in our own home in terms of installing a heat pump and how it's worked for us. I will start by giving a quick overview of the project before then going into the system design in a bit more detail. I think it's a useful example because hopefully I'm still here.
It's breaking up a little bit.
We've just had 2 short power cuts.
Oh, interesting. Okay, you're back. Yeah, we can hear you.
Back. Okay, that's good. Luckily, the router stayed on because that would have been a good 10 minutes.
That would have been sad. We can see some icons on the left. Sorry, I think I messed up your screen share from. I think it's gone back to.
Okay, no, that's fine.
No, it's okay.
I'm not sure that I can. It doesn't seem to want to expand more than that.
That's okay. You can see the slides. But
yeah, that's fine, isn't it?
Yeah, that's the main thing.
So I think it's a useful example case study because in many ways our house is fairly representative of an average house in the UK today, just in terms of the amount of heat it needs. And it's also a terraced house, which is fairly common. So I hope that at least part of what I've done are transferable, as it were. So the house is a mid-terraced house. It's got solid wall stone construction. The floor area is 77 meters square. And having done an energy assessment, the predicted heat demand is 9,700 kilowatt hours over a year. So it's pretty much the same as the UK average. When we bought the house a couple of years ago, it had a multi-fuel back boiler that didn't really work. So we ended up using a lot of direct electric heaters in the first winter, which wasn't much fun. So having already had experience with heat pumps from a previous project and my work, I knew I could get it to work even in a house with such poor building fabric. And although we intend to improve the building fabric as well, we needed to go ahead and get the heat pump installed before the winter that was coming, so we could at least get some heat into the house. So this is the heat pump. It's a Mitsubishi EcoDan 5 kilowatt air source heat pump. It's mounted on the back wall of the house with pipes going straight through into the bathroom. And the heat pump is connected to a central heating radiator system in the house pump hot water cylinder. Here's a picture of the living room radiators. You can just see them behind the sofas there. These are standard double panel convector radiators from Screwfix. They are sized to give a good performance at low flow temperatures, which I'll come back to shortly. And you can sort of see that by the fact that there's 2 quite large radiators there. Then in the bathroom, we have a hot water cylinder with a special large heat pump coil. This provides ample hot water for both showers, baths, etc. We've had the system in now for just over a year and a half, and we have had 2 winters, and this last winter with a little addition to the family, a baby girl called Ellen. So we needed it extra warm. This is, hopefully, can you hear me? Hello?
We can hear you, yes, we can. It might be better with if you switch the camera off for bandwidth, but there was a little bit of interference, but overall it seems okay.
That's strange because the lights have gone off in the house. Oh, maybe it's just affecting. That's strange.
You've got a local power cut, very localized.
Very local, yeah, that's weird.
Somebody can work that one out in the chat.
Yeah, bit worrying. It seems to be just the lighting circuit. Okay.
Okay, as long as you're all safe.
Yeah. So we've had the system in now for just over a year and a half. We've had 2 winters, and this last winter with a little addition to the family, baby girl called Ellen. So we needed it extra warm. The system has worked really well, providing plenty of heat, making it much more enjoyable to live in the house. So I'm now going to get a bit more technical. I'm going to talk about the performance of the system and then go over the design of the system in more detail. As you know from Andy's talk, a heat pump essentially uses to move heat from the outside of your house to the inside. The reason that a heat pump is better than a direct electric heater is that for every unit of electricity that you put into it, you typically get 2 to 4 units of heat into your house. This means a heat pump uses around a third of the energy of a direct electric system. The ratio between the heat output and the electricity input is called the coefficient of performance, or COP. So I was keen to monitor the performance of our system to see what kind of COP we were getting. I should say that energy monitoring is what I do for a living, because I've always been keen to understand how well these things work. I'm sure to install a good, I made sure to install a good quality metering on the system, both for electricity input and heat output. I then used our Open Energy Monitor system to read from these meters so that I could collect detailed data over time. You can see an example of that in the window there. I'm pleased to say that we managed to achieve an average COP of 3.92 for both space and water heating over the first year, which is pretty good really, considering that the average in the Energy Saving Trust heat pump trials in 2013 was about 2.5 for air source heat pumps. That means that based on the average grid carbon intensity in 2019, the heat pump delivered heat with 70% less CO2 than a gas boiler. Or in terms of cost, based on 15 pence per kilowatt hour electricity, each unit of heat costs about 3.8 pence per kilowatt hour, which is about the same cost as gas once you take into account the standing charge. So while the performance we have achieved from the heat pump is high, which is great, we have also achieved this with what are often thought of as non-ideal conditions, in particular, less than ideal building fabric and radiators rather than underfloor heating. So I'm now going to go into a bit more detail on the system design. So I had a lot of help with the installation and design from John Cantor, who Andy mentioned last time. So I've worked with John over the years on heat pump monitoring. John has a lifetime of experience with heat pump systems, and as Andy mentioned in the last talk, has written a great book on heat pumps that's worth reading. It's sort of an introductory book on heat pumps. If you're interested in doing the calculations for a heat pump yourself, a good place to start is with the MCS heat pump calculator. This is available through the MCS website. I've included the links there. The results give you the maximum heat demand for your house that your house will need at the coldest time of the year. It also tells you how much heat each room in your house needs so that you can match up the radiators or underfloor heating. An installer following the MCS standard will need to do these calculations for you. So you can always look at the results and discuss them with your installer. My calculation for the heat demand of our house during the coldest hours of the year suggested we would need 5.5 kilowatts of heat. And that might reduce down to 4.9 kilowatts if you take into account the small amount of heat given off by gains, so sources of heat in the house, such as lighting, appliances, and cooking, which are all giving a little bit of heat off, and also body heat and solar gains. So reflecting on our intention to improve building fabric and that we had a backup wood stove if it did get very cold, I decided to go with the smallest available Mitsubishi EcoDan heat pump, so the 5 kilowatt model, rather than a larger model with plenty of spare capacity. So from previous experience with heat pumps, I was aware that a smaller heat pump has a lower minimum heat output, which can help provide better efficiency during warmer times of the year. This choice has worked well for us. We haven't had any issues with not being able to deliver enough heat, but I don't really feel that I have enough experience with a wide variety of systems to give general advice on this particular point. So it's worth noting that a 5 kilowatt heat pump has ample capacity for the heat load at average January temperatures. So even though we're sizing it for this worst case -3 degrees, most of the time in January it's +5 degrees outside. And so the actual heat required by the house is much less. So the next step when designing a heat pump is to make sure that you have enough radiators or underfloor heating to emit that heat into your house at the water temperatures that make a heat pump work efficiently. At this point, it's probably useful to go over a couple of key concepts that are useful to understand when trying to get a heat pump and radiator system to work well. The performance of a heat pump is largely dictated by the Carnot COP equation. It's possible to estimate the COP that you would expect your heat pump to be providing by just knowing the outside temperature and the temperature of the warm water coming out of your heat pump. So that equation there is the sort of the basic version of the Carnot equation. There's a bit. If you're interested in the maths in a bit more detail, you might be interested in a page I put together there in that link there on these equations. So looking at the Mitsubishi Ecodan heat pump datasheet, the COP when the outside temperature is 2 degrees and flow temperature is 35 degrees should be 3.5. If the flow temperature is 60 degrees, this drops to a COP of 2. So boiler water heating systems, like a gas boiler, usually works at higher flow temperatures, around 60 to 70 degrees. And that's a lot higher than the flow temperatures that you want to design your heat pump system to achieve. If you look on, say, Screwfix for a radiator, it will usually state its heat output rating in watts. As an example, this standard double panel convector radiator has a stated heat output of just over 2 kilowatts. That is at a difference in temperature between the radiator and the room of 50 degrees, which means if your room is at 20 degrees, the radiator would need to be at 70 degrees. We can see in this table what happens if we reduce the temperature of the water going to the radiator to the ideal temperature for our heat pump, which is sort of around 30 to 35. So at 30 to 35, the ideal temperature, the radiator will emit between 8 and 5 times less heat than at 70 degrees Celsius. Then this means that you end up needing quite a bit more radiator area than you would need at boiler temperatures. Though it's not quite 5 to 8 times more, as you would typically run the heat pump for longer in the day than you would a gas boiler. And you can, of course, use underfloor heating, and you can also get fan-assisted radiators that provide a lot more heat output at low temperatures. So if you're struggling to find enough space for standard radiators, then it's worth looking at the fan-assisted radiators. Installing underfloor heating is in a retrofit case is obviously quite a large job, and it was beyond what we thought we could do here. And also the fan-assisted radiators, they're a lot more expensive than the normal radiators. So although I would have liked to have been able to design our radiator system to provide 5 kilowatts at a flow temperature of 30 degrees, I couldn't make that work without going for the much more expensive fan-assisted radiators. So I ended up going ahead with a radiator system that would provide 5 kilowatts at a water temperature of 41 degrees Celsius. So according to the datasheet, this should provide a COP of just under 3 during those coldest hours of the year, which is okay. It was reassuring to hear in the Carbon Corp webinar with Paul Kenny of Tipperary Energy that they also designed for a flow 40 to 45 degrees at -3 outside. So it's worth saying that if you can design for lower flow temperatures at -3, then that's even better. So at the average outside temperatures in January, the radiators, our radiator system would need to run at a water temperature of around 35 degrees, which should provide a COP of around 4 from the heat pump, which is much better. The drawing here on the left shows the positions of the radiators that we have in our house alongside the heat pump and the hot water cylinder there in the bathroom cupboard. For domestic hot water, we have a hot water cylinder with a special heat pump coil. The coil has a larger surface area than a standard coil and so works at lower temperatures, making the system more efficient. The coil is typically you want around 3 meters square of surface area on the coil. You can essentially order specific heat pump cylinders. So this one, the one that we've got here is from a company called Newark. That's the link there to their website. So discussing with John, I decided to go for a non-thermostatic shower mixer. My understanding is that thermostatic mixers introduce a slight trickle of cold water that mixes with the hot water at all times. And so you end up needing to keep the water in the cylinder hotter than you would otherwise need it to be. By using a basic mixer, I could just heat the cylinder to the right temperature for the shower without mixing any cold. I've been able to achieve pretty high COPs this way, but I'm not sure if it's really going a bit over the top. It means we have to be careful when we do a Legionella protection cycle to mix in a little cold water to get the right temperature. So it can be common now to use thermal stores rather than conventional cylinders to minimize or eliminate Legionella risk. Discussing the pros and cons with John, he had better experience with conventional cylinders with heat pump coils, and so I decided to take that route for our project. I would be interested though to learn more about thermal stores and compare the results from both. So this is the final design, the final system diagram, showing what we have installed in our house and an outline for the material costs of the system. I haven't included labor here as I did a fair bit of the work myself, alongside getting help from John and another friend with plumbing experience. You can see that the system in many ways is quite simple. There are relatively few components. Probably a couple of things to note is that it's good to get a low energy central heating pump, as the pumps run for much longer than a boiler system. The Wilo Pico is a good model. The main circuit is all 22 millimeters copper, with individual radiators branching off with 50 millimeters. So that reduces the work that having 22 millimeters copper all the way around as the main sort of circuit reduces the work the low energy pump needs to do. So in this last section, I will just go over a couple more examples of the monitoring results and talk a little about control as I go through these. Earlier in the year, I wrote a blog post assessing the performance of the heat pump over the first year. In addition to the high COP I mentioned before, we also use much less heat energy in total than the energy assessment suggested we should use. So the total amount of electricity consumed was 1,276 kilowatt hours, which cost us about £191 for the whole year. The largest reason for our reduced use of heat was that we're generally happy with lower indoor temperatures, or we were in that first year, than our standard. And the outside temperature was also warmer. I couldn't fully account for the difference. It might be that the U values are slightly better than I'd assumed, or that there's less air leakage, or that we were getting more heat from our neighbours, given that we're a mid-terrace. So this This here is an example of the indoor temperature in our living room last January. We achieved an average temperature of almost 19 degrees, and during the evening that was closer to 20 degrees. And that was more out of choice than anything. You know, we felt that that was plenty warm enough. And we had just had the little one, the little baby. We were conscious. We were conscious we needed to keep the house warm. So actually, the previous winter we would typically have it a little bit cooler, but this felt really comfortable. And I think part of the reason for that is because your walls are also at the same temperature as the air. So you know, that makes a slightly lower air temperature feel more comfortable. We were able to maintain this temperature while running the heat pump at 32% of its maximum capacity. So the average flow temperature when the heat pump was running was 31.5 degrees Celsius, and the average COP was 4, which is really good. And the heat pump was running at a low level for 80% of the time. The small dips in temperature that you can see there were partly switching to the hot water heat up cycle and sometimes leaving the system off for a couple of hours. Had we wanted more heat, we could have increased the flow temperature of the heat pump, as there was plenty of capacity spare. So we currently take a fairly simple approach to controlling the heat pump. We generally just set a fixed flow temperature for the space heating, typically 30 to 32 degrees, and then turn it on and off manually as needed. We can do this remotely and set a timer if needed, so that we can have it come on a good number of hours before we get home. I don't use the built-in weather compensation, that's built into the heat pump, as the house has a lot of thermal mass, and so it doesn't work as well. I basically end up doing weather compensation manually and always run at the lowest flow temperature I can. We usually turn the heat pump on well in advance of when we need the heat, so that we can heat the house up with a low flow temperature. During the coldest times of the year, if you're out, say, for work during the day, it can make sense to just leave the heat pump on all day. It can actually be more efficient this way than having it boost a lot of heat into the house over shorter time periods, as it would have to run at higher and so less efficient temperatures to do this. It's also better from a grid perspective, as you're not drawing so much electricity from the grid at peak times, as you've already heated the house up during the day. On that note, here's a graph of the electricity consumption of the heat pump throughout the month of January. And that's comparing it with, or it's applying the cost of the variable price Octopus Agile tariff. So this is a special tariff that an energy supply called Octopus do, and it varies in accordance with the wholesale electricity price. So the price keeps changing every half hour, and it's amazing how low the average price can be, even with those high evening peak rates. So the tariff between 4 p.m. and 7 p.m. the tariff goes up to sort of 25 pence, sometimes 30 pence per kilowatt hour. But the actual average unit price for the electricity, because the heat pump is running during the cheaper times of the day as well as the expensive times, is 10.6 pence for the electricity. So that's in January, and that works out to 2.6 pence per kilowatt hour for heat. And then the other months were a little bit lower there, all the way down to 2 pence in that April. And that's obviously quite a bit lower than gas, which is quite interesting. I was a bit worried to begin with that whether, because I was using a heat pump sometimes during the peak times, whether the price would be really high with this tariff, but actually it looks like it's really beneficial. I'm actually still waiting on Octopus to sort my smart meter, but I'm looking forward to get on this tariff once it's working. So that's it. Thank you for listening. I will leave this list of links up that might be of interest. If you haven't watched Paul Kenny's webinar, Paul Kenny of Tipperi's webinar on retrofitting domestic heat pumps, it was a Carbon Corp webinar a couple of weeks back. I'd really recommend watching that. Yeah, happy to answer any questions. Thank you.
Thank you, Trystan.
Was quite quick.
Very efficient. Wow, we're well ahead of time. That's never happened before. It's normally the opposite extreme. So congratulations. I think there's a few questions in the chat. I think Florence was happy to facilitate those. And I just quickly say beforehand that we'll definitely send the link to this webinar for everybody, so you can reference it and the previous one as well. We're doing that as practice, and yeah, this is ideally a study group as much as it is a presentation forum. So it'd be really nice to hear from people your questions and input into that. So yeah, fantastic. And yeah, you can get a copy rather than, you said, reading the links off the vid. Not sure. So yeah.
Back up. Just try and bring this back.
So we can we share your presentation as a PDF? Do we have permission to do that, Trystan? It's different when it's a Carbon Corp.
Yeah, absolutely.
Member. Are you happy for that? Okay. So Trystan's really kindly sharing it. So does that answer your question, Rupert? Hopefully it does.
Yes, thanks very much.
No problem.
So I'm trying to get the chat up here.
So you can see. I know Florence is answering some questions inside the chat. We've got one, maybe Trystan, while Florence is doing that, that's come in as well. We can multitask. Ellie and Josh have said, do EPCs ever factor into sizing the pump, or do installers always use MCS heat pump calculator? It's a good question. In terms of the energy performance certificate of the property, or would you just go on what MCS?
I think the sizing of the pump is based on the MCS heat pump calculator. But they do the RHI on the EPC, is that right?
Yeah, yes. That's right, yeah. So you need a recent EPC, so within the last 2 years, to access the renewable heat incentive if you're looking at that.
Yeah.
Somebody mentioned homely energy. I think that was Mark. If you must scroll up the chat. I've not heard of homely energy before.
Yeah, I don't know much about it. I had a really good chat with the guy behind Homely. I think what it is, it's a box that controls the heat pump and optimizes the time at which the heat pump runs to run at the cheapest time of the day, as it were. So I think they're working with the Octopus Agile tariff and sort of automating that control process while keeping a house warm. So it's sort of like a bit like a kind of hive thermostat, but designed specifically for heat pumps and to work with these dynamic tariffs.
Okay, good to know.
There's another question as well saying, should we we might do it in reverse, does that make sense? So the most recent one is probably easier to go that way. How noisy is the heat pump from Philip Massey to Florence and Trystan? Is it audible to neighbours or inside the house? And does it disturb the use of the garden? So maybe it would affect wildlife, maybe is implied there.
So there's, sorry. The
Sorry,
external,
carry on.
the external unit will hum. So if you're outside and it's on and working, you will hear it. But the rest of the system is pretty quiet, so you don't have the clanking of the pipes necessarily, and you don't have the boiler inside, so you don't have the pump there. So I don't know, what do you feel, Trystan? Have you got problems with neighbours?
No, haven't. Yeah, no problem with the neighbours. It's pretty quiet. And generally, if you, we've got a wall-mounted one here, and it's a little bit harder to get the noise dampening with the kind of brackets that you can get for those. Or, well, I think our bracket could be a bit better in terms of how much noise dampening is on it. Because you can get a little bit of vibration through into the back wall if you're not careful. So certainly if you have them ground mounted, you can get a really thick rubber footing for it, and also the way it's sort of on like a concrete plinth, but in the I think in soil, or in a way that it doesn't pass that vibration through into the house structure. You also have to, when you're, as part of the MCS guidance, there's the guidance for how to calculate the noise level at your neighbour's windows, essentially. And you have to make sure that it's not above a certain level. So that's all about making sure that you have the noise at the heat pump, and then the distance, and if there are any obstructions to the neighbour's window and so on. Yeah, I did those calculations for this one, and it was fine. But certainly, I think that could be quite challenging in some terraces. But it's generally they are very quiet, and compared to, you can actually hear a gas boiler go, it's almost louder almost sometimes. But then the heat pump is on for much longer usually, so it's something.
Yeah.
Also, Peter Mumford said he's got acoustic background and he's happy to give advice regarding noise more generally, which is great to have these skills in the group. That's fantastic. We've had an apology from Ken, who's joined a bit late, but I've just reminded Ken it's fine. Obviously got this pre-recorded, so it's no problem. But you have missed the presentation, sadly. Eleanor has said, how far from the house? Have you just answered that? Yes. Also, Peter's just said the limit apparently is 42. So dBA, I'm not exactly sure what these acoustic terms stand for, but I'm sure it's decibels. I think maybe someone else can interpret that, but you can do calculations, yeah, as Trystan's pointed out.
Yeah.
That's really interesting. Ken has also said you can install heat pumps on flat roofs. They used to do it a lot in London, so that's come through to me privately because I just messaged you privately, but I thought I'd share that with everyone. That's an interesting point from Ken. I didn't know that was possible. So that they can go on a flat roof.
Yeah.
Oh yeah, definitely.
So it's to do with the shock absorption in a way, I guess, as well as the positioning and distancing.
Yeah, so you'll have direct noise from the fan because it's a fan, and you've got the fact that it's vibrating, so that can go through the structure. That's what Trystan was talking about with the rubber footings. How far from the house can they go? I mean, most air conditioning units you can have about up to 50 meters away from the house or something. So, within a domestic setting, it's not really an issue but I'd keep to 10 meters, I think, to keep the efficiencies as high as possible.
Can you link up heat pumps with combi gas boilers, radiators, and existing underfloor heating? So you can, there's a configuration called a bivalent system. So that's where you combine a gas boiler with a heat pump. I guess to get good performance from the heat pump, it's a good idea to upgrade, to take out the boiler. Okay. Yeah, so I guess the key is to get good performance from the heat pump. You ideally want to make sure that radiator system is sized correctly for the heat pump. So you may find that you need to put larger radiators in. Generally, if I don't have a lot of experience with that. For this house here, there was already a central heating system running off a back boiler, but all the radiators were single panel radiators. They wouldn't have been able to provide enough heat, so we ended up changing all the radiators in the house. But I guess it's hard to say really whether a whole new system is needed. That would be probably, it's very much on a per. You'd have to, each system would have to be looked at, because I guess some modern gas system lines run at lower temperatures, and so they will put in larger radiators. But I don't know whether that. I imagine you'd still need to increase at least a few of them. But I don't know the answer to that in very much on a case-by-case basis, isn't it?
Yeah, you probably just have to evaluate the sizes and types of radiators that you've got at the moment, and see if you can get the output out for your room temperature.
I think I've missed a couple of questions going back now.
Yeah.
It's quite hard to keep track in the chat.
Yeah.
They keep popping in.
How frequently do you need to raise the temperature to prevent Legionella in the hot water?
That was a really good question.
Can this be timed to avoid conflicting with usage patterns? So I think there's a whole load of different advice on this. It's not my area of expertise, but I think generally people say sort of once a week or once every 2 weeks.
Yeah, that's what I've put in the chat. And it's usually timed to be in the middle of the night, but I think you can agree that with your installer.
Yeah,
that's good.
How does it do the heat loss calculation?
Did you already see the question, which I've gone right back to the beginning, saying any reason you didn't have just one massive radiator versus the two smaller ones? Was it an add-on rather than an upgrade from Ian Duncan? I don't know if you addressed that.
Say again, sorry.
Did you address that question? So it was any reason you didn't have one massive radiator versus the two smaller ones? Was it an add-on rather than an upgrade?
Okay.
Yeah, so that an answer in that, but
that's this. I'll bring that up here. Is the screen share still working there? It seems to be sort of suggesting it's only half of the screen here.
I can, we can see it, but we can see your slides on the side, but that's fine because we're in the chat mode now, so don't worry.
Okay. So I put in two there. I think you just can't quite get a radiator that long in a single size. Also, that particular size, the 1.2 meters by 600 millimeters, is like a really standard size for radiators, and it's the cheapest radiator you can buy on, well, cheapest sort of, you get better value for money with that particular size by quite a significant margin on Screwfix. So I ended up just getting lots of those radiators.
Sounds very pragmatic.
Yeah.
I was just going to say it'll be quite difficult to get the water to flow through the whole radiator and maintain those average temperatures as well. So there'll be a pressure drop issue and a temperature drop issue across the whole radiator. It's probably more efficient doing it the way you've done.
Right. Yeah.
That's really interesting. Is that because obviously the scale means that, yeah, the larger the radiator, the harder it is for that consistency for the heat to travel round, basically. Yeah. It requires more energy to push it round. Does that, do you think that covers that? With the pressure drop? Yeah. Sorry, I've just seen that Florence is answering loads of things. Sorry, Florence. And you addressed the underfloor heating question from Matthew as well, who said they had an air source heat pump fitted in December with an upgrade to radiators, but they're considering an extension should they get the underfloor to maximise efficiency.
Yeah.
And you said heat pumps can be added on to existing house systems, yeah, such as gas heated underfloor heating. Underfloor heating is very comfortable as well.
Yeah.
If you can afford it. I had it in a previous house and it was really nice. And because it runs at a lower level, it's complementary to the heat pump system as well. I know I'm repeating what you said, but
yeah, that's fine.
There's one here. How hard was it to do the heat loss calculations, and where do you go to get the U values?
that's a good question.
It is a bit tricky. I mean, I feel it's well worth doing it if you're keen to get into the numbers of this thing. So there's quite a bit of guidance on the MCS website, and also if you have a look on the link to my blog on the heat pumps, there's also a lot. I've documented a lot of the kind of loss calculations and assessment stuff there. You basically go around your house, measuring it all up, creating a floor plan, and then selecting the right U values is obviously a big part of it. And there is I think it's like a U value booklet or guide that the MCS on the MCS resources page you can download. So that's really helpful, but it's also just useful then just to get some additional kind of background. There's some interesting papers from Historic Scotland, say, on stone wall U values that give a slightly different values that you can use if you've got that construction.
Yeah, so you can approach it in two ways probably. If you know your wall construction, you can find out the overall U value across that build up, and there are sort of online calculators that you can use, or you could, if your house is relatively new, you could look at building standards, building regulations for that particular decade or whatever, and you could just use those as a reference point if you haven't done anything to your fabric. And there will be, I think it's Historic Scotland that have some typical U values for certain types of house and period. I don't know if the EPC gives any of that information. Can't remember. I'll have a look. But yeah, there are various ways of calculating the U values. Yeah. Oh my goodness, 11 new messages.
Is there an optimum speed for the heat pump for max efficiency? So I guess the efficiency does vary with. So the main thing is the flow temperature coming from the heat pump and what the outside temperature is. Efficiency. But there is also a contribution. If you look on the heat pump data sheet, on the EcoDan one from Mitsubishi, there's a low speed, a medium, and a high or maximum output. So they just correspond to sort of different levels at which the compressor is running at, and the medium is usually a little bit more efficient than the lowest. But depending on how you've got your radiator system set up, it can still be better just to drop that flow temperature, even if you're going into that low section. There's a bit of a there's an optimum point, but it's yeah, you sort of have to work it out on the basis of each system, as it were.
The 60-degree Legionella using an immersion heater, or is that still using a heat pump? So generally you get the immersion heater to do that extra bit of temperature uplift, I would say.
There's an old question here from Ian as well. I don't know if you'd answered it, but it said, I'm renovating now, going for radiators rather than underfloor, brackets cost and complexity. It's end tariff, so all very relevant, hoping to use sun amp batteries in place of hot water cylinder. Could you talk a little more about your decision to use a cylinder?
Yeah, sure. My understanding of the sun amp battery is very interesting, and I had a little bit of a look into that. I think at the moment you have, so it's a phase change material, and in order to make the phase change work, you have to give it a slightly higher temperature than I need to drive the cylinder with. So it would be a bit less efficient if I used the sun amp. But I know they are working on a lower temperature version that would work better with heat pumps. I mean, it'll still work with the heat pump, but you just get less efficient results than you would with, or sort of in a basic, looking at it in a sort of basic sense. I haven't actually tested one out myself. I have data to compare, but from my understanding is that you need to drive it at a higher temperature. But it is very interesting because it's takes up so much less space, and it's also obviously it's storing the heat in the phase change material, and then you're passing cold water into it. When you draw water from it, so when you draw hot water, it's heating up that water instantly as it passes through this material, or through the heat exchanger in this material. And so you don't have any issues with the Legionella, which is also another advantage. But that is also, the other alternative is to use a thermal store, and that's got the same approach. So it's got the water that you're drawing off from it coming through a heat exchanger and being heated up instantly. And so doesn't have that Legionella risk as well. But the hot water cylinder approach, it was something I'd discussed with John Cantor, who he's got a lot more experience about these things than I do. He's worked in heat pumps for years, and he's had much better results with the cylinder approach in terms of the efficiency. But he can see how a thermal store could provide good results with the right control, but has found it a little bit more tricky to get that to work as well. But it's definitely something I think an interesting approach that I'd like to learn more about.
That's great. Do you want to add anything, Florence? Or is that, I think that's covered in that question.
About hot water cylinder.
Yes. Do you have anything to add to it, or?
We will go through what the options are for hot water in the next session. But Trystan did mention a thermal store, and that is one way to avoid having to lift the temperature up to 60 degrees every so often. But it will work a bit like on a combi boiler, where your mains cold water passes through the tank, and then you get instantaneous hot water, as opposed to using your hot water directly from the tank. So there are pros and cons for either solution.
That's really interesting. Thank you. A question from John Warwick as well. Can you tell us more about the work that you can do yourself? That's quite a broad question. I don't know how you might both want to approach that. That's a big question for you.
I think changing radiators and that kind of thing is, I mean, depends how much experience you have with plumbing, I guess, doesn't it? It's all fairly straightforward stuff, but certainly there are certain requirements where you have to get someone in, like if you've got an unvented cylinder, you need to get a registered person to do that, and the heat pump unit itself needs to be done by someone who's got the right tickets. Yeah. In terms of the rest of the central heating system, I'm not entirely sure that that's I think my understanding is that you can do, like, put in a radiator.
But would you attempt it? So the heat pump comes under the F-gas regulations, so it needs a specialist installer, because the pipes contain refrigerant gas.
Well, that's if you're not doing any. If the heat pump is a monoblock system, and the only thing you're connecting is water. Certainly, if you're doing a split type, that would be.
That's a good point.
Do you want me to keep scrolling down and then put them to you both? Is that working best? I know there's lots of questions still appearing, but we've still got a bit of time if everyone's okay to stay on. Is that okay?
So here about the amount of space in the house for the cylinder.
Okay, that's relevant.
That's just all. I've got the cylinder, the meters, and the indoor unit of the indoor sort of control unit for the heat pump. That's all in the airing cupboard. It's only a relatively small number of components, but yeah, you sort of need a. I'm not entirely sure what the dimensions of our airing cupboard is. It's not that big, but there's a little bit of space there. This picture here probably gives it an idea of what of the amount of space it all takes up.
That's good.
Can an air source heat pump be used for cooling in the summer with underfloor heating? So I think that you have to get a specific type of air source heat pump for that. I'm not aware that the Mitsubishi Ikodan can't do cooling.
Also, I read that you can only, if you get both, if it has dual function, it's less efficient both ways as well, apparently. Is that right? I read that somewhere recently when we were presenting the introduction to home energy systems. It just said that if it is a dual function and you're using it as an aircon as well as a heater, it won't be as efficient either way. But whether that's definitely correct, don't know.
I'm not sure about that.
Not sure. Okay.
You'd have to specify a reversible air source heat pump
Mhm.
to do the air conditioning. I mean, they exist.
Yeah.
If you're going for the renewable heat incentive, though, that doesn't count, I don't think.
Falls through. Yeah.
But you have to go for heating only.
Another question here, is there a simple way to measure heat input and heat output of a heat pump without extra meters? So obviously if you can ideally, I mean to measure heat output accurately, ideally you want a flow meter that's in line with the with the circuit, and those are quite expensive. You can get a good idea for the performance of a heat pump if you just measure the electricity going into it and the flow and return, and because and also the ambient temperature if it's an air source heat pump. I mentioned earlier the Carnot efficiency equation. You can sort of get an idea for what the performance of the heat pump is, so the flow temperature and the outside temperature. It's obviously not super precise, but you can certainly learn a lot from that. To do heat output, you could work backwards to an estimate of heat output, but it wouldn't be particularly accurate, I think. There's definitely different things you can do there in terms of the monitoring approach.
There's another question on monitoring from Peter, but it's is there any way of estimating how much heat energy your current gas heating outputs into your rooms and hot water?
I guess you could, if you could get the spec for each radiator and then measure the temperature of the radiator, work out roughly what the heat output of each radiator is and sort of add them up. I haven't tried doing it that way, but in theory that should work. But that would be very much a kind of spot measurement rather than like heat energy output over time.
Yeah. That's great. Rupert asked, how did you do on energy efficiency in your case study, Trystan? He said your demand is 125 kilowatt hours per meter squared, which seems relatively high. No criticism given fabric.
Yeah, sure. So yeah, the building fabric. I'll go back to that slide here. So you can sort of see there in the corner the 126 kilowatt hours per meter square. Pretty awful. Like I said, the intention is to improve. I'd like to improve the building fabric, do some retrofit work to improve that. I guess, and perhaps it's surprising that the heat pump worked so well considering that, but hopefully in the presentation it's sort of gone through why that was the case. In the monitoring section, so I actually ended up using 45% less energy than that assessment suggested, with the kind of real world figures. So it was actually putting 69 kilowatt hours per meter square over the year. And that was partly just because of having slightly lower, lower indoor temperatures, but also there was a contribution, about a third of that, which I couldn't fully account for, which may be that the U values were slightly better than what I used in the assessment, or it could mean that we're getting a bit more heat from neighbours or something like that. So I've started work on and trying to on a retrofit assessment, so working out what we could do to improve that building fabric. It's one of the things I'd like to look at next. I guess we have been able to maintain a comfortable temperature even without improving that building fabric, and that's been maintained while still running the heat pump at sort of 32% of its available capacity in January. So we have a lot more scope to increase the heat output if we needed to. It's not to say that we should. Certainly improving the efficiency would be a good thing to do.
That's an impressive that it's only running at 32% and it's still sufficient. That's great.
Yeah. So I guess that's just because the average temperatures in January are much higher than those extremes. And so the heat pump only just about meets the extreme requirement, but has plenty of capacity for the average temperature, which is worth kind of realizing how those things that difference between that extreme requirement and the average in say January, which is the coldest month.
Yeah. On the subject of the temperature, then they do like to perform at colder temperatures, don't they? Heat pumps. Somebody queried previously. Not in this session so much, but yeah. What is the ideal kind of performance temperature for them, if there is one, or like bracket temperature of the outdoors, so to speak, if it was outside on the side of the house?
Oh, what's the ideal
ambient?
Ambient temperature. My understanding is, isn't it the higher the outside temperature, the better?
That's what I thought. Yeah, unless someone had misinterpreted in the webinar we ran on the Monday. So when the temperature drops below 0, the heat pump's efficiency drops because it's more likely to freeze up, and therefore you have to run it backwards, and that will create. You'll have to use energy, obviously, to do that, and then its efficiency goes down. Is that correct? Just to qualify that.
Yeah,
that's
absolutely.
Part of it, but it's also harder to extract heat from a lower temperature source. So
that's what I assumed. Yeah. So they don't really like to run it at super low temperature outside.
That's it. Yeah, and also if it's a combination of low temperature and high relative humidity outside, so it'll start icing up quicker if it's colder and it's more moisture in the air.
That makes sense.
And then so that usually starts happening sort of below 4 or 5, well, about 4 degrees. Depending on the relative humidity.
Great, that's really interesting. Did you see the question from Paul Hadfield, both of you, with regarding the thermal mass? Did you consider switching the heat pump off every afternoon between 4 and 7? Paul asked, with your high thermal mass.
Yeah, I did. I tried that. So it works fine in the kind of shoulder months, when it's not too cold. But if in the middle of January, if I turn it off at 4, you really start feeling it after about an hour. So, and then it just takes just feels like it takes ages to come back up again. So what I do instead is I run it at a very low level, so the actual electricity consumption of the heat pump right on its minimum through those hours, but the temperature in the house is then without dropping.
Good answer. So you've covered some of these now. I'll leave you to look at them.
Is there a reason I went for Mitsubishi? Mainly because of John's experience with the Mitsubishi heat pumps, and he's also got the he was supplying the heat pump. I guess had I very interested in the main problem with the EcoDan is that it's got the high global warming refrigerant in it. So if the refrigerant leaks, it relatively high amount of global warming potential compared with some of these. There's some newer models coming out now that use propane or CO2. I think the propane one's particularly interesting. Yeah, I'm not entirely sure which manufacturer that is, but it's certainly the way that they all need to go. They need to go towards the lower global warming potential refrigerants.
That's great. Margaret said in Cambridge, planners require air source heat pumps to be 1 metre from the boundary for noise reduction. So that's not a question, it's more of a statement about the specific area requirement in terms of the planning authority by the sound of it. So can it vary, I guess, from authority to authority then? Or is that a normal requirement?
I think it probably varies.
Yeah, that makes sense. Annoying, but makes sense.
There's definitely some, if you've some areas where you can't have the heat pump in front of your house, from a kind of visual aesthetic perspective, isn't there? In certain places.
Carla asked, can a layout of the piping system affect noise, or is that more mechanical with mechanical ventilation systems?
Layout of the piping for the heat pump. Yeah, not.
No, it's not the same issue as with ventilation ducts, as in you don't get noise travelling down the pipes as you do with air, and also you don't get noise from air in. You don't get noise necessary from the water in pipes unless this, the system's not been installed properly. You shouldn't, but it's the same as any radiator system. If you've got if you can hear trickling in a radiator system, you'll get it whether it's a heat pump or a boiler system. But a well-designed system doesn't make that trickling noise. So yeah.
That's a good answer. Got one here from Rupert. If you're an upper floor flat, do you think you could have installed this kind of heat pump?
Yeah, I don't really know the answer to that one.
Depends whether you've got an outdoor space available for the unit, really. And
and you can get the wall brackets, but I don't know how that would work in a flat context.
So there's so many messages. I'm just trying to go through them.
Yes, good.
It's a good
point
sign.
by Paul. Well, there, but if I put external insulation, say on the house here, that high thermal mass would be available to be charged up with the heat from the heat pump, and so the temperature wouldn't drop that much. That would be. I did a little bit of sort of energy modeling work on that, and it does look really promising.
So Rupert makes a point about the amount of energy that an EPC says and a heat pump supplier says compared with actual heating energy. Yeah, I mean, EPCs and how your consumption is calculated, you know, they follow set rules, and if you use your heating system differently to the average person, then you will find that your real energy use is very different. Also, the EPC will only cover regulated energy use. So, you know, if you're talking electricity, it'll underestimate that. And the HP, and if you've done energy efficiency improvements, that's not necessarily reflected in your EPC unless you get an updated EPC done. I don't know if that makes sense.
Question here about why is zoning a bad idea for heat pumps? I don't know so much about zoning. I mean, I just say what we've done in our house here. So we actually do run all the rooms, run heat into all the radiators at all times, just because we need them. It's a relatively small house, and we need that sort of surface area of those radiators to be able to bring that temperature down, for it to stop, so that it doesn't start cycling essentially. So but yeah, it's a fairly small house, so and we use pretty much all the rooms as well.
Yeah.
I think you have to. I think you have to,
house, there's no reason why you wouldn't zone it.
Yeah.
And you could operate at different temperatures for bedrooms and, you know, top floor, whatever.
You have to be careful, don't you? Not that they don't sort of switch on and off.
Yeah. So Ken Bone has said because heat pumps like to work with large volumes of water. So yeah. So if you have a larger installation, then zoning makes more sense than if you have a small one. And yes, you can have TRVs with a heat pump system.
Someone said, can you have a Nest thermostat, I think that says, on an almost set and forget basis, because you mentioned having to switch the heat pump off before you needed it, kind of thing.
Yeah. I think you can. Yeah.
Yeah, there's no reason why you couldn't have your own control system, but as someone said in the chat, I think a lot of these installations, that, you know, the supplier will have their own control.
Yeah, actually, there's sort of two aspects of control, isn't there? There's when you turn it on and off, and that's just a sort of any thermostat or controller can connect to that input on the heat pump. You can connect your Nest thermostat to that. Then the other aspect is this flow temperature, and you can adjust that on the controller itself that comes with the heat pump, or you can set it to be based on the room temperature, and you can set to use as weather compensation. So there are a couple of different modes that you can use. You can certainly have it without doing the kind of manual approach that I'm doing.
Any chance of getting a green grant as well as the RHI? I don't think there's much detail out yet about.
It's too early. Even though it has to be done by March, but we still don't
know. But so far they've only lumped it in as renewable energy efficiency measures. So it could be insulation, it could be technology, it could be whatever, as far as I can tell. But watch this space. Someone's asked about NIBE ASHPs. I've not heard of NIBE.
NIBE.
Oh. NIBE.
I think, I mean, you can, I've had, yeah, they do good quality heat pump. There were some bad results with kind of exhaust air heat pumps that they provided to some social housing, I think, but I think that was just more to do with installation. I mean,
right, yes, the little compact things. Yeah.
Yeah, I think generally that was one of the points that Paul Kenny made, was that the performance, or how good it works, is more to do with the rest of the installation and how well it's installed. Than you can get a bad heat pump and good installation and it'll work quite well, but you can't get a good heat pump and a bad installation and have it work well, as it were.
That's a very interesting point around how procurement's really important. And I think Florence is going to go into that, aren't you? Around how to pick an installer. It's very important.
Yes, I'm not sure if I've got to the bottom of it, but I can pass on experiences, yes.
Got 60 messages in total coming in that I haven't yet seen. Sorry, I'm not keeping on top of these.
So Ken seems to have a bit of experience. Maybe he could say how he chose his installer. Maybe he is an installer.
Ken, do you want to contribute that?
There you go. I've installed loads of NIBE. Oh, there you go.
Right. Yeah, I've also heard good things about NIBE. There's a question here from Chris. Have you considered a house battery to avoid the 4 to 7 agile peak? I'm really interested in that approach. That could work well, I think. Relatively small battery, I think. Essentially, generally in January, the heat pump is running at about 500 watts, so 0.5 kilowatt hours per hour. So 4 till 7, 3 hours. 1.5 kilowatt hours. So even like a 4 kilowatt hour battery would be plenty. You'd get us through that peak. And I'm also interested in looking at, say, a relatively small solar PV system mounted on the shed, maybe 1.5 kilowatts or 2 kilowatts, charging a small battery to then run the heat pump in the kind of shoulder, well, more for hot water really. So then you'd use it, charge the battery, and then run the heat pump to do the hot water. I'd like to look into. Obviously, PV doesn't coincide well with the winter demand for heat, but you do use your heat pump for hot water in the summer, so you can still use a PV with a heat pump for your hot water side of things.
Don made a really good point, actually, and that's one I wondered about. He said, I believe it's just made it some heat pumps have a backup electric heater that can make the running costs more expensive, question mark.
Sorry, say that again.
Don's just mentioned, I believe some heat pumps can have a backup electric heater that can make the running cost more expensive.
Yeah, that's definitely one of the big concerns. So a lot of the examples that had really bad performance in the past, that was being caused by these backup electric heaters that are in line, and we didn't install one in ours specifically so that it would never come on, and it was also reassuring to hear that from Paul from Debris Energy in the other webinar, that they don't install any backup systems either.
Ken mentions you have to change the settings for backup heater on commissioning, and I think most modern heat pumps might not even have a backup heater. They just have they just run it in reverse with a defrost cycle. Some do, some don't. There you go.
Yeah, I know with the EcoDan, it's sort of you can install it as an additional item and then connect it to the controller via relay.
Did you see the question from David about brands? He said, if we're looking at specifics, how about Stiebel or Stiebel Eltron? I'm being offered that, or EcoDan.
So I don't know. I haven't got any experience with Stiebel heat pumps, but I did find an interesting section in the BRE on heat pump efficiency. They've got an entire database for all the heat pumps that we did a study on, and you can filter by manufacturer and flow temperatures and heat source and that kind of stuff, and it'll give you the sort of season. I think it gives you the COP over at those particular temperatures, and you can compare different heat pump types. So I think it'd be interesting to have a look at that and maybe compare a few for the next session.
Ian Duncan had some good points about the refrigerant, in that, even if it did leak, it's due to impact, the heat pump is still much better than a gas boiler. And I think I read studies that say only a relatively small amount of it does not typically leak, so that the actual impact is relatively small across all the heat pumps. But it definitely is important that refrigerant is collected at the end of life, if it's assuming it's still there and hasn't leaked. Any views on how to get customers to take up heat pumps, given my experience?
I wouldn't push any kind of technology on any customer, but you can only do the numbers and run the numbers and show them what the impacts are for the various choices they make. And it might be that they could do a deep retrofit and go straight to full electric if they wanted to. So but you're right in that it's not simple, and getting the right installation isn't simple. So there's quite a big psychological jump from switching to a heat pump from a boiler system, because everyone knows how the boiler works. So yeah, we can only just keep doing what we're doing.
I think Paul Kenny's example from his webinar of their experience in rolling out, or that they offer a retrofit and heat pump installation service. We've done a large number of systems now, and it's really fascinating to hear their experience.
Yeah,
It's just really sort of a compelling package, really, and worked out, done really well.
yeah, definitely having good precedents will help, won't it? Because so far it's not got the best publicity, and there have been some problematic installations in the past. So so the more we get in good examples.
Yeah, and they did a lot of they worked with lots of mixture of heat pump installers and standard plumbers. They did a lot of the calculations in-house, and then gave the installer the details of the system to install. And once they saw the results, the good results that were coming from that, they're really happy to work with it.
Yeah, I think Paul's job was slightly easier though, because he was switching lots of people from oil. So economically speaking, that was definitely more viable. But when people are switching from gas, the numbers don't always stack up, so it's quite hard. Is that we run out of time?
Yeah, I was going to say we'll have to wrap up shortly, sadly. I think there's just 2 minutes.
Has anyone not had their question answered that might want to raise their hand? Or
any burning last minute questions that need to be answered now? Because what we'll do is we'll carry over this list through the chat, and we'll capture those comments and questions and have a working document that we can share with the group in order to capture anything that may have been missed out. So we'll annotate that after the event, and then that will get sent through to participants along with Trystan's presentation. So if that helps clarify bits and bobs that we haven't been able to cover, I think that's probably the best approach time-wise.
absolutely.
Because it seems like there's a lot to cover. So thank you so much, Trystan and Florence. It's been brilliant and really, really enjoyable.
Thank you. Yeah, that's really great. Thanks.
And thanks to everyone on the call. I'll quickly grab all this chat commentary before we shut the webinar, and wish you all a very good evening, and hopefully we'll hear from you on the next webinar too. So if you have questions after this session, then please email them. You can email them to myself, or I think Trystan's put his details here if you've got ones you want specifically answered by Trystan, but we'll carry them over to the next session. So please feel free to do that. So my email is polly@carbon.coop, and hopefully you'll have, I'll forward Trystan's contact and Florence's as well, so you'll have those if that's okay with you both.
Yes.
Try and copy the link.
Pop it in the chat before we wrap up, and then people can hopefully.
There's the link to Paul's webinar if anyone's interested in that.
Sure they will be. It seems like there's a lot of
a lot of love for that one.
There is. Yeah. Absolutely. It's been wonderful. Thank you, everybody. And we're looking forward to the next one. So the next one isn't until is it the 12th of August? So you've got a bit of a break. So please go away, have a think, decompress, consolidate what you've learned and what you still need to learn, and then come back to us with some questions for the next session. And don't forget to sign up in Eventbrite if you haven't already done so. If there's any problems with Zoom link, just email me as well, and I'll get you the link over. Great.
Great, thank you very much.
Thanks, everyone. Take care, guys.
Good evening. Bye.
Have a good evening, everyone. I think have you got the host control?
Ah.
I don't know if it's you. If I press leave, I don't end the meeting for everyone. I don't think.
Okay, I'll see if I can.
Wonderful. I'm just making sure I've got the chat copied, and I have, so that's great.
You're still recording.